If we were to shrink the Earth we live on by 1 billion times, turning it into a blue glass marble, just 1 centimeter in diameter, how big would the observable universe actually be? Let's start from Earth. At this scale, the tallest structure ever built by humans, the Burj Khalifa, would be only 0.0008 millimeters tall, no more than a speck of dust on the surface of the marble. The highest mountain on Earth, Mount Everest, would measure just 0.09 millimeters, like the faintest scratch on your fingernail, barely visible even with a magnifying glass. And you, my friend, who stands 1.8 meters tall, would shrink down to only 1.8 nanometers. At this point, you can no longer call yourself small like dust, because visible light has a wavelength of 400 to 700 nanometers. When a wave of light passes over you, it wouldn't even ripple, you wouldn't block it, you wouldn't cast a shadow. You would be lighter than something that can be seen, like a particle of air that doesn't exist to the eye at all. But once we step beyond Earth, you begin to realize just how unimaginably vast the universe really is. The moon, the closest world to us, shrinks into a grey pebble only 0.7 centimeters across, hanging 38 centimeters away, about the distance of an outstretched arm, an ordinary distance in daily life, yet one that carried the greatest leap in human spaceflight history. From 1969 to 1972, 12 human beings crossed this arm's length and left their footprints on another stone in space. To this day, it remains the farthest place humans have ever personally set foot. Moving outward, Mercury becomes a 0.38 centimeter lead pellet, racing tightly around the Sun. Venus grows to nearly 1 centimeter, almost the same size as Earth, yet its surface burns hot enough to melt metal. Mars shrinks to just 0.53 centimeters, a rust-colored grain of sand, with our robotic explorers slowly crawling across it, like beetles climbing tiny dunes. Jupiter expands to nearly 11 centimeters, like a striped grapefruit, the big brother of the planets, that nearly became a second sun. Inside it, a massive storm has raged for more than 4 centuries. Wider than the entire Earth itself, beside Jupiter sits Saturn, about 9.4 centimeters in diameter, and if its rings were fully spread out, they could cover an entire dining table. Uranus and Neptune, each around 4 centimeters wide, quiet cold ice giants, standing guard at the edge of the solar system. At the center of all these worlds lies the heart of the solar system, the sun that sustains us. At this scale, the sun is 1.09 meters across, standing 117 meters away, roughly the length of a soccer field. Walk outward another 1.17 kilometers, and you reach the Oort cloud, the true boundary of the solar system. In this model, the entire solar system is just a territory about 2.3 kilometers wide. The nearest star beyond it, Proxima Centauri, is only a 1.5 centimeter red dwarf, yet it lies 310 kilometers away, roughly the distance from Beijing to Jinan. Light takes 4 years to cross that gap, while humans would need 70,000 years. The brightest star in our night sky, Sirius, measures only 2.5 centimeters here, yet shines 20 times brighter than the sun. Even so, within the Milky Way, it is still just another ordinary star. As we pull the camera back further, we enter the scale of the galaxy. At this size, the Milky Way spans about 1 million kilometers, enough to travel between Earth and the Moon 1,300 times. Our solar system sits on a spiral arm, 26.0 kilometers from the galactic center. In other words, we don't live in the heart of the galaxy, we live in its quiet suburbs. At the center of the Milky Way lurks Sagittarius A*, a black hole from which even light cannot escape. Its mass equals 4.3 million suns. Yet at this scale, its event horizon is only 0.06 millimeters wide, a point smaller than a grain of sand, holding enough mass to tear a solar system apart. Beyond the Milky Way lies the Local Group, a collection of more than 20 galaxies. Our galaxy is merely an average-sized member. The Andromeda Galaxy, 2.5 million light-years away, twice the size of the Milky Way, appears here as nothing more than a faint speck, and when its light finally reaches Earth, it shows us Andromeda as it was 2.5 million years ago. Back then, our ancestors had only just learned to walk upright. If a civilization in Andromeda were observing us now, they wouldn't see city lights, they would see early humans wandering the African savanna. The diameter of the observable universe is about 93 billion light-years, yet this is only a small fraction of what exists. Imagine the universe as an expanding balloon. The observable universe is just a portion of the surface we can still see. The true universe may be far larger. Scientists estimate its diameter could be at least 250 times greater than what we can observe. But because space itself is expanding faster than light, 97% of galaxies will never send light that reaches Earth. We are trapped inside a visible cage, staring at the tip of a cosmic iceberg, forever unable to see its full form. Within this vast space, at least 250 times larger than the observable universe, there may be entirely different physical laws, structures beyond our imagination, and countless civilizations like ours. Yet they and we will remain forever separated by different light cones. Every direction our telescopes point reveals light emitted 13.8 billion years ago, and since that light began its journey, the universe has expanded for another 13.8 billion years, carrying those galaxies far beyond our reach. So at this scale, what are we? If the universe were an ocean, the observable universe would be a single water molecule. Earth would be an atom inside that molecule, and you and I wouldn't even qualify as a quark within that atom. Our lives are vanishingly brief on cosmic timescales. From the Big Bang to Earth's formation took 9.2 billion years. From the first life to humanity, 3.5 billion years. From the rise of civilization to this sentence, 10,000 years. A human life, about 80 years, leaves almost no mark in the universe's record. If the 13.8 billion year history of the universe were compressed into a single year, human civilization would appear in the last minute of the final day, and your entire life would last just 0.05 seconds within that minute. That 0.05 seconds is all the time you truly have. The universe will not remember us, but the people you love will. The words you write will remain, the trees you plant will keep growing, and the warmth you pass on will continue through others. In those fleeting 0.05 seconds, every choice you make writes a story that is eternal in its own way.